Hello, this is Dr. Rody, and in this video I'm going to go over a quick and simple method for using the TI84 or 83 calculator to find Z critical values. You may find yourself in a statistics course needing to find these critical values for confidence intervals, doing minimum sample size questions for confidence intervals, or hypothesis testing. This shows you how to use the calculator rather than using tables or trying to interpolate between values. With this method, you can find the critical value for any percentage. So first, what is a critical value? It's the value in the given distribution, in this case a Z. Now a Z is a normal distribution with mean of 0 and standard deviation 1. And it's the values of Z along the horizontal axis here that will result in a given percentage between them. In other words, the middle percentage. And what I'm showing here really, it turns out, is the middle 95%. So this would be, if let's say you had a confidence interval of 95%. It turns out what I've drawn here is the 95% middle interval. And it turns out that this value here, if you looked it up in a table, if you do that old method, you would see that it would be between negative 1.96 and positive 1.96. And the critical value is really the absolute value, so it's going to be the positive number here, the 1.96. So that is the critical value for a 95% interval. But how do you find that using the TI calculator? So what we do is we use actually the Z interval command. I'm going to hit the stat button. I'm going to go over to tests, and I'm going to pick a Z interval, which in this calculator is number 7. I can arrow down to it or just hit 7. And then I'm going to say I have stats. And what I'm going to do is force it to be a normal 0, 1. So my sigma, my population standard deviation, I'll put in 1. I'll put in 0 as my mean here. And then I'm going to say my sample size is 1. And I'll explain later why that works. Then you put in the confidence level. So this is 0.95 or 95%. And then when you hit calculate, you'll be given these values as a confidence interval. And so the interval here shows that 1.96, the positive value, that would be the critical value for a 95% interval. So 1.96 is the critical value for a 95% confidence interval if you were doing a Z interval. This is particularly useful if you're doing those problems where you're determining minimum sample size for a mean or a proportion, and you need to find this Z value. Sometimes the book calls it Z star, and also occasionally it's called Z alpha over 2. So for any given percentage, if you need this critical value, you can simply use this technique by going to the Z interval and then indicating a mean of 0, standard deviation of 1, n equal to 1, and then just put in whatever confidence interval you need, whatever confidence level I should say. Okay, now I'm going to explain the Z alpha over 2 notation that you might encounter, and then I'm also going to explain why this works. Alpha is 1 minus the confidence interval. So if my confidence level is 95%, then my alpha, 1 minus 95, is 0.05. And so what then is alpha over 2? Alpha over 2 would be half of 0.05, which is 0.025. That should be a decimal. There we go. So if I use this technique to find the values in the Z distribution that capture 95% between them, and I get this 1.96, that's the critical value for a 95% interval, but it's also the critical value for an alpha of 0.05. I have this formula, and I want to find the critical value Z star, which is the value that will give me a certain given middle percentage. Well, what I did is by using that Z interval command, it's using this formula. And remember, I said, make x bar equal to 0, make sigma equal to 1, and then n equal to 1. So if I run that through this formula, right? You can probably see what's going to happen already. Well, 1 over the square root of 1 is just 1, right? Because the square root of 1 is equal to 1. So this all reduces down to negative z. I'm putting a little star to indicate critical value. And so this is the interval that's created. Now we're not really doing a confidence interval for a for a problem, but this is what the program is doing. And so you get this interval of negative z star to z star, right? And so for the critical value, we want the absolute value, so that's going to be that number. So when we ran it for 95%, we got negative 1.96 to 1.96.